When current flows through a conductor, magnetic fields are formed, and this field can affect circuit operations. And to relate with the effect of this magnetic field, the term inductance was born. What is inductance? Inductance is the propensity or likelihood of an electric conductor to oppose the change in current flowing through it. The direction of this magnetic field relates to the direction of flow of the current through the conductor and is depicted by the right hand rule. With the hand folded in this position, the thumb represents the flow of the current, while the folded fingers represents the direction of the magnetic field, as can be seen with the ring about the conductor. Inductance majorly affects the circuit by slowing down the change of electric flow, that is current. Therefore, it resists change in current. No abrupt increase or decrease of current. The inductor resists instantaneous change. It only allows the change in current to be gradual. Intentionally, circuit components are made to possess just this capacity, since useful, and are called inductors. They are also called chokes. Inductors are simply a coil of wire whose magnetic field at different points of the wire intersect and join up to form the bigger magnetic field across the coils. Inductance is measured in Henry. When we have constant current flowing through the inductor functions just like a straight wire with no induced voltage across its ends. When we have an increase in current, a voltage is induced across the inductor to resist the increase in current. If there is a reduction in current flow, a voltage is induced across the inductor by the magnetic field with intent to keep the current flowing at same pace. The right hand rule can also be used to determine the direction of the flux, but this time if the thumb points to the direction of the flux, then the other four fingers point in the direction of the current. Inductors can have their coils wound around the material, and this material is called a core. Its essence is to increase the magnetic field and thus the inductance. Cores can be classified into two: ferromagnetic cores, also called iron core, and non-ferromagnetic cores, also called air cores, because they have same permeability as air. For the iron core, induced voltage is N d phi over dt, where phi equals to flux and is measured in Webers, N equal to number of turns, T is equal to time in seconds. And for the air core, it is L di dt, where L is inductance, di dt is the rate of change of current. An approximate inductance of an inductor can be determined by L equal to mu n squared A all over L, where L is length of the coil, A is area of the coil, N is number of turns, mu is permeability of the core. Inductors can be connected in series and in parallel. If connected in series, effective inductance equals sum of the inductances of the individual inductors, as seen in the example we have. If connected in parallel, we have L1 L2 divided by L1 plus L2 as our effective inductance.